Hello, today we're gonna prove a short lemma about invertible elements and non-vanishing. So let A be a ring as usual, and the claim is that if we have an invertible element in the ring, if and only if for all points in the spectrum, f evaluated at this point is non-zero. And the evaluation, as usual, is to be considered as, so we have a prime ideal x here, and we consider f, so the class of f, in A mod x, or maybe also in the field of fractions of A mod x. Okay, so that's the statement. Now let's prove it. So let's rephrase the right-hand side. So the right-hand side is just equivalent to, for all points in the spectrum, f is not in the prime ideal. Okay, well, that's exactly this statement here. And now let's see how we can get to the left-hand side. So if f is not in the prime ideal, then I claim that the ideal generated by f has to be 1, so if it's in no prime ideal. Because if it was, so by the existence of maximal ideals, we would have that if it's the ideal generated by the f was not A, that it's in a maximal ideal. But on the other hand, if the ideal generated by f is equal to A, then it can't be in any maximal ideal, so it can also be in no prime ideal, which gives us that this is an equivalence. And now I claim that this is equivalent to f being invertible, and that's also straightforward. So let's say f is invertible, then we find an element g such that f times g is 1, and so we have that 1 is in the ideal generated by f, and if 1 is in this ideal, then we can multiply with any other element in the ring, and we get that the ideal generated by f is A. And if we have this thing here, then we get that there's an element such that f times g is 1, and that means that it's invertible. So that was quite straightforward, and we'll use this lemma to prove. So we wanted to prove about, let me remind you what our goal is. So we want to look at the map spec of the localization. Then we have a map. So this is induced by localization to the spectrum of A. So phi goes from A to AF inverse, which sends A to A over 1. And we want to prove that this map here is an open embedding with image d of f. So this was spec A minus the vanishing of f. So we want to show this. Actually, for this, we don't need the lemma, but we want to show some special properties of the localization. So they are, in some sense, I don't know the right word for it now, but they are have a universal property for certain maps to the spectrum. But we'll see this in the next video. So this was a short video, and in the next video we'll go on about so we'll deal with what I just said. Okay, so thanks for watching and have a good time. Bye.